All right, imagine this. Your website, your app, everything's humming along, everything's running smoothly, and then, boom, the entire data center, poof, it goes dark. Total nightmare, right?
Yeah.
But what if it didn't have to be a nightmare? What if your mission critical applications, they just kind of shrugged it off,
Well,
like it was no big deal.
yeah, like a digital safety net.
Exactly. That's the
Hmm.
power of high availability, and that's exactly what we're going to be diving into today with a Kubernetes cluster that we're going to spread across 3 data centers.
Yeah, it's all about making sure your business stays online, even if one entire location goes completely offline.
Yeah. So no matter what, something is running.
Mhm.
And we've got this fantastic technical document that we're going to be looking at today that really digs into all the nuts and bolts of this. And it's not just theory. This is packed with like real world examples, real world considerations. So let's unpack this, starting with the why. Why is high availability so mission critical these days?
Well, think about it. I mean, the world runs on digital services now, right? Everything from online banking to shopping, healthcare.
Yeah,
It's
it's pretty much everything at this point.
pretty much everything. And any outage, even a short one, can just have this massive ripple effect. I mean, think about lost revenue, damage to your reputation, you know.
Yeah, you lose trust if your systems are constantly going down.
Absolutely.
People are just going to go somewhere else.
Right. So spreading a Kubernetes cluster, across different geographic locations is like having, multiple backup generators. If one fails, the others are there to pick up the slack and keep things running smoothly.
So even if one data center goes down, the other two can, keep things chugging along.
Yeah. Ideally, that's the goal.
Okay, but I'm guessing it's not quite as simple as just copying and pasting the cluster, right?
Oh, absolutely not.
What?
There are a lot of things to think about, and one of the big ones is network latency.
Okay, latency. So is that just a fancy word for lag? Like when I'm trying to play an online game and my connection's terrible?
That's actually a perfect analogy.
Yeah.
Latency is just the time it takes for data to travel between points in a network.
Yeah.
And just like in your game, even small delays can cause big problems in a Kubernetes cluster, especially for, critical components.
So give me an example. Like what kind of critical component are we talking about?
So one of the most important ones is et cetera. You can think of et cetera as like the brain of your Kubernetes cluster. It stores all this vital information, and it helps all the different parts of the cluster work together, talk to each other,
Right, keep everything in sync.
exactly. And so if the latency between the data centers is too high, this communication starts getting disrupted, and then you have all sorts of problems. Instability, you could even have data loss. It's like, imagine trying to have a conversation with someone, and the phone keeps cutting out, every other word.
Yeah, you can't get anything
It's
done.
impossible to get anything done.
So how much latency is too much? Like what's the magic number?
Well, most experts recommend keeping latency under 10 milliseconds between data centers,
Hmm.
which, that's incredibly fast, by the way.
Yeah, that doesn't sound like a lot of time.
It's not. In fact, the document that we were looking at, they actually highlight an example where they achieved an average latency of 2 milliseconds.
Wow, 2 milliseconds. That's crazy fast. How do you even pull that off across different locations?
It's a lot of different things coming together. Dedicated fiber optic connections, really carefully planned network routes, and sometimes, they actually strategically place the data centers closer together to minimize the physical distance that the data has to travel.
Oh, so it's like
Yeah.
it's like a combination of, the physical infrastructure and then the network engineering.
Exactly. It's a real engineering feat to pull off 2 milliseconds.
That's pretty impressive. Okay, so low latency, check. Now back to that brain of the cluster, that et cetera. How do you configure that in a multi-data center setup?
Okay, so this is where it gets really interesting. So, et cetera needs something called a quorum to make decisions. It's kind of like, a voting committee. You need a majority present to make any critical decisions,
Yeah.
even if one member is unavailable.
So majority rules even in the world of Kubernetes.
Exactly. And so in a 3 data center setup, a common strategy is to have one et cetera node in each data center.
Okay, so if one data center goes down, the other 2 nodes can still, keep making decisions. Pretty clever.
Yeah, it's a good system.
But I'm sensing a but coming.
Well, of course there's a but. You always have to find a balance, right?
Yeah.
Because more et cetera nodes, that means more redundancy. But if you spread them out across high latency links, that can actually slow things down.
Oh, I see.
It's like having your committee meeting where everybody's miles apart.
Yeah.
It just takes forever to get anything done.
So you need to find that sweet spot between fault tolerance and performance.
Yeah, exactly. Exactly. It's about understanding the trade-offs and making the choices that optimize the whole system, not just one part of it.
All right, so we've got low latency. We've got our et cetera configured for high availability. What else is what else is critical when you're spreading a Kubernetes cluster across multiple data centers?
Well, you can't forget about the Kubernetes API. I mean,
Hmm.
this is how users and applications, this is how they interact with the cluster. It's like the front door to your house. It needs to be accessible even if one of the data centers goes down.
Right, because if the API goes down, nobody can manage or access anything running in the cluster.
Exactly. It's a total roadblock.
Oh yeah, that's a big problem.
And that's where load balancing comes in. It's like having, a traffic comp. They're directing users to the right data center, even if one's having problems.
Okay, so what are some of the load balancing options that are out there?
There are a lot of popular solutions. HA proxy and keep alive, those are commonly used.
Hmm.
Another one is kubevip. That one's known for being really simple and easy to set up. But they all essentially do the same thing. They make sure that the Kubernetes API is up and running, no matter what's happening at the data center level.
So you've got all these different tools working in the background, keeping the API accessible, even if a data center melts down. It's like having a whole team of air traffic controllers just making sure everything runs smoothly. All right, so far so good. What's next on the high availability checklist?
Okay, so now we need to talk about pod placement. Pods are where your applications actually live within the Kubernetes cluster, right?
Okay, so that's where the actual work is happening.
Right, that's where the magic happens. And Kubernetes has this really cool feature called topology-aware pod scheduling, which means it can intelligently distribute your pods across those three data centers.
Ah, so we're not putting all our eggs in one basket?
Precisely. If one data center goes down, you don't want to lose all your applications running.
Right, definitely not.
And we can even go a step further with something called pod anti-affinity rules.
Okay, now we're getting into the weeds a little bit here. What do these anti-affinity rules do?
They prevent all replicas of an application from being scheduled in the same location.
So it's like having a backup generator for your backup generator.
Exactly. Even if a whole data center goes offline, you'll still have some instances of your app running in the other data centers.
All right, so we've got our low latency network, we've got our cleverly configured, et cetera. We've got our load balancers working their magic, and now we're strategically placing our pods across multiple data centers. Anything else we need to keep in mind?
Absolutely. We need to figure out how to handle all the traffic that's coming into our cluster. You know, all the users trying to access our website, our app, whatever it is.
Right, because what good is a highly available application if nobody can reach it?
Exactly. It's all about access. And that's where ingress traffic management comes in.
Okay, so how do we manage this ingress traffic in a multi-data center setup?
Well, you need a combination of internal and external load balancing. It's like a really well-coordinated traffic system, right?
Okay.
So you've got your internal load balancers, like MetalLB or Cilium. They direct traffic within the cluster. And then you have your external load balancers. They act like traffic cops outside the city, routing users to the healthiest and closest data center.
So it's like a whole network of traffic signals, just making sure everything flows smoothly, no matter which data center a user connects to.
That's a great way to think about it. And of course, you need to keep an eye on everything, monitoring your network performance, checking, et cetera, health, making sure the whole cluster is running as expected. All of that's part of the high availability package.
Okay, so it's not just a set it and forget it kind of thing.
Oh, no, not at all. It's a very active process.
All right. Well, I think we've covered a ton of ground already. Before we move on, can you give us a quick recap of the key takeaways?
Sure. So for maximum high availability, when you're spanning a Kubernetes cluster across multiple data centers, you need low latency between those data centers. You need those distributed control plane nodes. You need robust load balancing for both the Kubernetes API and for incoming traffic. You need strategically placed pods using those anti-affinity rules that we talked about. And of course, you need constant monitoring. You got to make sure everything's running as it should.
Okay, that's a lot to take in, but I think we've built a really good foundation for understanding how these multi-data center Kubernetes clusters actually work.
Yeah, I think we've covered the technical details really well. But it's important to remember that the success of this kind of setup, it also depends on how well it's managed, right? You need a good understanding of the infrastructure behind it.
Absolutely. So it's not just the technology, it's the people, it's the processes, it's everything working together.
Neglected.
All right. So speaking of understanding, we'll be right back after a quick
Just kidding. We're diving right into part two, where we're going to explore some real-world applications of this
Hmm.
and the unique challenges that they bring. So stay tuned.
Okay, so we've kind of laid out the technical blueprints here for a multi-data center Kubernetes cluster, but let's shift gears a little bit and talk about where this actually gets used in the real world. What kind of situations really demand this level of high availability?
Yeah, you got to think about industries where even a few minutes of downtime can be absolutely catastrophic.
Yeah.
Finance, healthcare, e-commerce, telecommunications. For these businesses, a multi-data center Kubernetes setup, it's not just a nice to have, it's a must have.
Yeah, it's mission critical. So we're talking about a bank processing millions of transactions
Yeah.
or a hospital monitoring critical patient data.
Exactly. Places where even a tiny hiccup
Yeah.
can have these huge ripple
Yeah,
effects.
you don't want systems going down in those scenarios.
Absolutely not.
And the source material really emphasizes this point that achieving this level of resilience.
It's not just about the technology itself.
Right.
It's about operational excellence.
Okay, you mentioned operational excellence. What does that actually mean in this context?
It's about having the right processes, the right tools, and the expertise in place to manage this really complex infrastructure
Mm.
effectively. Think about it like a Formula One racing team.
Okay.
You need these highly skilled engineers, mechanics, strategists,
Hmm.
all working together seamlessly to keep that car performing at its peak.
Right, so it's a team effort.
Yeah, and it's same for a multi-data center Kubernetes setup. You need rock-solid monitoring, you need disaster recovery plans, security protocols, and a team that knows how to handle any situation that comes up.
Right, because even the most advanced technology is only as good as the people managing it. So
Exactly.
we're not just talking about servers and networks here, we're talking about building a whole culture of preparedness.
Yeah, a culture of resilience.
And that brings us to another important consideration. The cost factor. High availability doesn't come cheap, does it?
It does come with a price tag.
Yeah.
Setting up and maintaining multiple data centers, those super fast connections we were talking about,
Yeah.
implementing all the necessary security measures, it all requires a significant investment.
Yeah, it sounds like it.
Organizations need to really weigh the cost against the potential risks of downtime.
So it's like a balancing act.
It is.
You're investing in resilience to protect yourself against potentially huge losses down the line.
Exactly.
And it's not just the initial setup cost.
No, you've got ongoing operational expenses too.
Yeah.
Electricity, bandwidth, maintenance, and of course, the specialized skills you need to keep everything running smoothly.
Right. So it's a long-term commitment. Right. But for those businesses we were talking about earlier, the finance, the healthcare, the e-commerce, I mean, the cost of downtime is probably far greater than the cost of prevention.
Oh, absolutely.
Yeah.
For them, it's not even a question of if they can afford it. It's can they afford not to do it?
Right. It's a necessity.
The potential financial losses, the damage to their reputation, that could easily dwarf the cost of building a highly available system.
Okay. So cost is definitely a factor, but for a lot of businesses, it's just a necessity in today's world. Any other real-world considerations that we should be thinking about here?
Yeah, there's another aspect that's often overlooked, but it's absolutely crucial. Data governance and compliance.
No, right. Especially with a multi-data center setup. You could be spread across different countries, different regions.
Exactly. When you're replicating data across multiple data centers,
Yeah.
you have to be extremely mindful of data privacy regulations.
Yeah.
Different regions might have different laws about how that data can be stored and accessed.
Yeah, like GDPR in Europe, for example.
Precisely.
Yeah.
You need to make sure your data management practices, they comply with all the relevant regulations, no matter where your data is physically located.
So it can get complicated.
It can get very complicated. You might need legal expertise, data encryption, carefully designed access controls.
So it's not just about building a resilient system, it's about building a responsible one.
Very well said. And it highlights a broader point, I think. High availability, it's not just an IT concern, it's a business-wide concern.
Yeah, it affects everybody.
It requires collaboration between the technical teams, the legal departments, compliance officers, even senior management. Everyone needs to be on the same page to make sure all the bases are covered.
It sounds like achieving true high availability requires this really holistic approach.
I think that's a good way to put it.
You're not just thinking about the technology, you're thinking about the operational, the financial, the legal, even the ethical implications.
It's a big responsibility,
It is.
but it's one that more and more organizations are having to shoulder as we become more reliant on digital infrastructure.
All right, so we've discussed real-world applications, operational excellence, cost considerations, data governance. What else is there to uncover in this deep dive?
I think it's important to leave our listeners with one final and perhaps unexpected consideration.
Mm.
We've been really focused on the technical and operational aspects of high availability. But there's another dimension that's equally important, the human element.
Oh, okay, the human element. I like that. Tell me more. What do you mean by that?
Well, no matter how well designed your system is,
Mm.
it's ultimately people who build it, people who operate it, people who respond when things go wrong. And humans, as we all know, are prone to errors, biases, fatigue.
Yeah, we're not perfect.
Not at all.
Even the most seasoned IT professional can make a mistake, especially under pressure.
Exactly. So when you're designing a highly available system, you have to factor in human fallibility.
Okay, so how do you do that?
Well, it means building in safeguards, things like automated checks, clear documentation, robust training programs.
So it's almost like designing a system that's mistake proof, or at least as mistake resistant as possible.
That's a great way to put it. You need to anticipate those potential errors
Yeah.
and build in mechanisms to prevent them or at least mitigate them.
So give me some examples. Like what kind of mechanisms are we talking about?
Things like redundancy, failover mechanisms,
Yeah.
clear escalation procedures. So if something does go wrong, you know exactly who to contact, what steps to take.
So it's not just about preventing the technical failures, it's about preventing the human errors that can lead to downtime.
Precisely. And it really emphasizes the importance of a culture of continuous improvement. You need to constantly monitor, analyze, learn from any incidents that occur, even the minor ones.
Right, because even a small hiccup can reveal a bigger problem.
Exactly. High availability is not a destination, it's a journey.
I like that.
It requires this constant commitment to learning, adapting, improving.
Well said. I think that's a perfect segue into our final thoughts for this deep dive. So we've really journeyed through like the intricate world of these multi-data center Kubernetes clusters. We've looked at the technical nuts and bolts, the real world challenges, and even, that human element.
Yeah, it's amazing to me how high availability really is about so much more than just picking the right technology. It's understanding how the technology, the operations, and even the people, how it all fits together to create a truly resilient system.
Yeah, it's like a finely tuned machine where every part has to be in top shape for the whole thing to work flawlessly.
Yeah, exactly. And as we rely more and more on digital services, I think this whole concept of high availability, it's only going to become more crucial. It's not just for, a few select industries anymore. It's becoming like a fundamental requirement for businesses of all shapes and sizes.
Yeah, it's like the electricity that powers our modern world. We kind of take it for granted, until the lights go out.
That's a great analogy, yeah. Just like we have, backup generators and emergency plans for power outages, we need to have that same level of preparedness for our digital infrastructure.
So what's the one key takeaway that you really want our listeners to walk away with today?
I really want them to understand that high availability is an ongoing journey. It's not a one-time fix. It's a continuous process of learning, adapting, and improving. It requires a shift in mindset, almost a cultural change within organizations to really embrace this importance of resilience.
Yeah, it's moving beyond that reactive firefighting mode and really embracing a more proactive approach, to prevent problems before they even happen.
Exactly. It's about anticipating those potential failures, building in redundancy, testing your systems rigorously, and having clear plans in place for when things inevitably go wrong.
Because let's face it, in the world of technology, things are going to go wrong. It's not a matter of if, it's a matter of when.
Absolutely. And the difference between a minor inconvenience and a major disaster often comes down to how prepared you are for those inevitable failures.
So it's not about eliminating risk entirely. It's about managing it effectively.
That's a great way to put it, yeah.
And that requires that holistic approach that we've been talking about, thinking about not just the technology, but also the people, the processes, the culture of the organization.
You got it.
Well said. I think we've given our listeners a lot to ponder today. But before we wrap up, I want to leave them with one final thought, something to really spark their imagination.
Okay, I'm all ears.
So we've talked about the power of these multi-data center setups for high availability, but what if we took that concept a step further? What if we envisioned a future where where applications could seamlessly migrate between
Hmm.
any available computing resource anywhere in the world in response to failures or demand spikes or even cost fluctuations.
Hmm. That's a fascinating idea. It's like taking cloud computing to a whole new level where applications are truly location independent
Yeah.
and can just, adapt to these changing conditions on the fly.
Yeah, exactly. It would require this whole new level of infrastructure abstraction and automation,
Oh, absolutely.
but it could revolutionize the way we think about high availability and application resilience.
Yeah, it's like a glimpse into a future where the lines
Yeah.
between physical locations and even cloud providers could become increasingly blurred. A truly interconnected and resilient digital world.
And that's where we'll leave you today, listeners. Food for thought as you continue your own exploration into the ever evolving world of high availability. Until next time, keep learning, keep innovating, and keep those applications running smoothly.